In this section, we continue our study of oblique triangles and discover how to use the law of cosines to solve these triangles. Let's begin. Section 8.3, the law of cosines. So we use the law of cosines to solve triangles that are in the form of SAS and SSS. In particular, what you're missing is a complete pair, like we had in the law of sines. In the law of sines, you had to have at least one complete pair, an angle and the side across from that angle in the triangle. You'll use the law of cosines when you don't have that pair. And then what you usually do is use the law of cosines for the first step to complete a pair, and then you go back to the law of sines for the rest of it. So let's go ahead and prove the law of cosines. It's a pretty short proof. So the law of cosines says the following. For a triangle with sides little a, little b, and little c, and the opposite angles a, b, and c, then c squared is equal to a squared plus b squared minus 2ab times the cosine of c. Now there are other ways that you can permute the letters, but the basic idea is the following. The quantity that is on the side by itself that is squared is the opposite angle it's the opposite side to the angle that's given in the cosine here. So the c squared and the cosine of c, those go together, and then you're just going to have the other two sides floating around within this formula here. So let's go ahead and prove this. So basically, suppose that you were given little a, little b, and angle c, and then we want to draw a figure and then solve for c. Now, basically what this is saying is, suppose that you're given two sides and the included angle. How could you draw this triangle? Well, actually, because a triangle is rigid under transformations, we can set it up so that one vertex of the triangle is at the origin. And you can just move the triangle around, no big deal, and rotate it however. And we can also set it up so that a second vertex is on the positive x-axis. The third vertex can be over here somewhere. This one is arbitrary because it might actually be in the second quadrant. Doesn't matter. So this is going to be the origin, O, but then we'll also call that angle C. And then we'll have angle A here in the corner and angle B up here at the top. Now we were given side B, so that's going to be the distance along the x-axis. Since that is the distance along the x-axis, that means this point over here is the point B comma 0. We were also given side A, and that has to be across from angle A. Check. And then we have this side here, which is side C. So we have the origin, 0, 0, point B, 0, and now what are the coordinates of this point here at the angle that is B? So what you want to do, and I'll sort of annotate this a little bit and then take it away, but you want to pretend like this is some sort of unit circle here. And with that, you can think of this point as being partly the cosine of the angle at the origin, which is C, and sine of the angle at the origin, which is C. But it's not necessarily a unit circle with radius 1. Instead, it would have the radius of A. So we just scale it up by multiplying by A. So this point is A cosine of angle C, and the y-coordinate is A times the sine of angle C. Now what we want to do is find the side length C. So we're going to go with C squared is equal to the distance from point A to point B squared. So C is the distance from A to B. We square both sides. No big deal. And the reason I squared both sides is because I want to use the distance formula, but I want it to have, I want it without the square root. So now it's just the difference in the x's. So the x coordinate at point A is b, minus the x coordinate at point B is a times the cosine of c. That's squared. Plus, now it's the difference in the y's. The y coordinate at point A is 0, and the y coordinate at point B is a times the sine of c. And we square that as well. Now let's multiply all this out. Remember, when you square a binomial, you square the first one, so we get b squared. And then it's times the two pieces times 2. So it's going to be 2ab times the cosine of c. And then you square the last piece. So it'll be plus a squared times the cosine squared of c. And then we'll just square this piece because that's a 0. So it becomes plus a squared times the sine squared of c. And notice that the last terms both have a squared in them, so I can factor out a squared. And that leaves us with the very familiar cosine squared plus sine squared, which is 1. So that's just going to turn into a 1, and this is a squared plus b squared minus 2ab times the cosine of c. And that's the law of cosines. Let's see how to use the law of cosines in example number 1. Solve the triangle. A is equal to 5, B is equal to 9, and angle C is equal to 40. So I'll just draw a little triangle here. I don't know exactly what it looks like, so I'll just draw something here. Let's see, we have A. A is 5, B is 9, and we have the angle C that is 40 degrees. Now, whenever you look at solving the triangle, what you want to ask is, what type of triangle is it? This one is a side angle side. And in other words, you don't have a complete pair. You have angle C, but you don't have the side across from it. You have side B, but you don't have angle B. And you have side A, but you don't have the angle across from it. So now we use the law of cosines. So we'll call this side C, and we have c squared is equal to a squared plus b squared minus 2ab times the cosine of c. We plug in the sides, so we get 5 squared plus 9 squared minus 2 times 5 times 9 times the cosine of 40 degrees. If you work out the right side, you get that c squared is equal to 37.06. And then c is equal to, by taking the square root, you get 6.09. So now we have side C, which is 6.09. Now, we need to find another angle, and the question is, which angle should we go for? Should we go for angle B, or should we go for angle A? And this is where it gets a little bit tricky. The answer is you should go for the smaller angle. when you're doing the law of cosines and then going into the law of sines. And the reason is because of the following. We know that angle A is across from the side that measures 5. Angle C, which is 40 degrees, is across from the side that measures 6.09. And angle B is across from the side that measures 9. We also know that the order that the angles are in also determines the order that the sides are in. In other words, since the side lengths are increasing, going down, so are the angle measures going down. This tells us which one is going to be smaller out of the two that are left, A or B. And we need to go for A. Now the other reason is, or in addition to, is how would we find angle B? And the answer is we would use the law of sines. And we would have the sine of B over 9 is equal to the sine of 40 divided by 6.09. And the problem is when we try to work this out, the calculator is going to give us an acute angle for B. What we don't know at this moment is whether or not B is acute or if it is obtuse. If B is obtuse, doing the law of sines is not going to tell us that. And so we can't go for B at this moment. We know that every triangle has at least 2 acute angles. That is always true, even if it's a right triangle. A right triangle would have a 90-degree angle and then 2 other acute angles. An obtuse triangle has the obtuse angle and then 2 other acute angles. So we know that angle A must be acute because it's the smallest angle of the triangle since it is across from the smallest side. Angle B might be acute, but it also might be obtuse. For that matter, it might be a right angle. Doubt it, but you never know, right? So we can't use the law of sines to go for the larger angle here. We got to go for the smaller one first. So let's do that. So now let's go for angle A. So sine A over the side across from A, which is 5, is equal to the sine of 40 degrees divided by 6.09. This gives me 6.09 times the sine of A is equal to 5 times the sine of 40 degrees. Divide and take the arc sine, and you get A is equal to 31.85 degrees. That is acute, and that does make sense with what we know so far. The angle A needed to be smaller than 40 degrees since it was across from the side that was smaller than 6.09. And now what do we do with the B? Now we just use the fact that the sum of the angles of a triangle is 180, and we'll see what we ended up with here. So 180 minus 31.85 minus 40 degrees is equal to 108.15. So it was, in fact, an obtuse angle. And had we done this law of sine stuff, we would not have figured that out. So make sure you go for the smaller angle on these law of cosine problems. Example number 2. Solve the triangle C equals 12, B is equal to 15, and A is equal to 8. So let's draw a little sketch of the triangle here. And B is the long one, so I'll put B up there, make this one C, and make this one A. Again, it doesn't really matter, but I do like to try to get it close whenever I can. So we have 8, 12, and 15. Now, what are we missing here? We're missing all three of the angles. Now, based on our previous discussion, the law of sines and the sine function would not tell us if the angle is acute or obtuse. However, the cosine function will tell us that. So what we want to do is use the cosine function here, law of cosines, and we want to go for the largest angle. And this works because the cosine of an angle in the first quadrant is positive, but the cosine of an angle in the second quadrant is negative. So if we start messing around with this and we end up with a suitable answer where the cosine of some angle is negative, then that's going to give us the obtuse angle, which is really what we want to find. So the obtuse angle, if there is any on this one, now they may all be acute, but if there is one, which angle would that be? Well, it would be the angle across from the side that is the longest side, 15. So it's the angle B that we would want. So let's go for B. So let's rewrite the law of cosines in terms of B here. So B squared is equal to A squared plus C squared minus 2AC times the cosine of B. Before I plug that in, let's go ahead and solve this for the cosine of B. So first, let me just move the A squared over and the C squared over. The right side is now negative 2AC times the cosine of B. And then I'll divide by negative 2AC. Now, some people like to write it like this. They take the negative from the bottom and change the sign of everything on top. That's pretty good too. So basically, they take the negative from the bottom and distribute it through the numerator and get A squared plus C squared minus B squared. So let's plug in the numbers that we have now. So the cosine of B is equal to A squared is going to be 8 squared plus C squared is 12 squared minus B squared is 15 squared over 2 times 8 times C, 12. Work that out, take the arc cosine, and you get that B is equal to 95.08 degrees. So we have found the largest angle. It is obtuse, and we wouldn't have been able to find it had we not used the law of cosines first. Now we know that both of the angles left are acute. We can find either one, your choice. I'm going for A. So the sine of A divided by 8 is equal to the sine of 95.08 degrees divided by 15. Cross multiply. 15 times the sine of A is equal to 8 times the sine of 95.08. Divide by 15 and take the arc sine, and you get that A is equal to 32.09 degrees. And then lastly, angle C is equal to 180 minus 32.09 degrees minus 95.08 degrees. And that's equal to 52.83 degrees. Let's look at example 3. Ship A left port heading south 20 degrees west and traveled 40 miles. Ship B left the same port traveling south 30 degrees east and traveled 75 miles. How far apart are the two ships? So let's draw the scenario here with a coordinate grid. Ship A left port heading 20 degrees west of south. It's going to be this direction and went 40 miles. Ship B left the same port heading 30 degrees east of south. It's going to be a little bit wider, but the ship traveled 75 miles, so I'll bring that out to here. There's 30 degrees, like so. And then the question is, how far apart are the two ships? So how far apart are they? So basically what we have is a triangle. We have 50 degrees in this corner from the 30 and 20 put together. We have 40, we have 75, and we have x. And the question is, can you use the law of sines, or do you need to use the law of cosines on this? You don't have a complete pair. You have two sides, but not their opposite angles. You have an angle, but not the opposite side. So this one is going to be law of cosines. So it's going to be x squared is equal to 40 squared plus 75 squared minus 2 times 40 times 75 times the cosine of 50 degrees If you work out the right side, you get that x squared is equal to 68.27. Taking the square root, you get x is equal to 58.04